Many compounds are made up of ions. Ions are when you have an atom that has gained or lost electrons and it has a charge. The charge can be positive or negative. An anion is when the charge is negative, and that means that it has gained electrons. Electrons are negative, so that's why it makes the atom negative when it gains. A positive ion is a cation. These have lost electrons, so the positive charge comes from the protons they have that are extra or more than their electrons. You need to keep these two names straight. Anion has an N there for negative, and cation has a T, which is kind of like a plus sign. The thing is, when these come together to make a compound, overall the compound will be neutral. It will have no net charge. We can predict the charge of ion that an element can form using the periodic table. It's a really simple trend. These in the first column form a +1 ion. These in the second column tend to form a +2. And then we skip these in the middle because they're pretty complicated, harder to predict. This is the +3 column. This is the -3, -2, -1. Noble gases here on the end don't tend to form electrons, so I don't have those there. Also, I should tell you that below this stair step that separates the metals and the non-metals, those trends don't work down here. Aluminum is +3, does form a +3 ion, but some of these down here do not. So for 6 columns, we can pretty much make predictions on what kind of charge they'll form. So as far as naming the ion, if you wanted to say, what is this Li +1, for a positive ion or a cation, you just use the element name. And that's actually kind of not too effective, because when you have the neutral atom, it's called lithium, and when you have the charged atom, it's called lithium, and it's hard to tell which one you're talking about. And since this is cut off, let's put anion up here. For an anion name, it's a little better because you use the element name, but then you use an "ide" ending. So it distinguishes it. In other words, like this ion, that's the neutral atom would be fluorine, but we use an "ide" ending for the anion. So some metals can have more than one common charge, and these are listed on your Symbols to Memorize handout. It's found under Helpful Documents. These are a lot of those metals that are in that middle part of the periodic table, and for these we can't just say like lead. We have to say lead and which one, because lead can be either +2 or +4. So the way we specify that is with the Roman number that tells us the charge. So there's lead 2, and then lead also forms a +4. So +2 or +4. There's an old-fashioned way to name these as well. We use the plum for the lead, and the lower of the two numbers gets S, and the higher of the two numbers gets ick. So plumbic is the higher of the two common lead ions. This also works the same for like copper. Copper can do a +1 and a +2. Those are its common ions. The copper 1 is also called cuprous for the lower, and for the higher it's cupric. Now I don't use these old-fashioned names that much. I usually use the Roman numbers, but you need to be familiar with them because you'll see them elsewhere. Next thing is polyatomic ions. Sometimes you have groups of atoms that form an ion as a whole. So like ammonium This is ammonium. This is a group of atoms that are very well connected together, and overall they have this +1 charge. Those polyatomic ions are very stable. When you have a reaction that includes something like ammonium chloride, when it reacts, it's very likely that that will remain intact. Not always, but often they remain together. So they're groups of atoms that are relatively stable. And again, you need to memorize some of these. They're on your symbols to memorize handout under helpful documents.